In this video, we are going to look at computational thinking as we in the project Colette are using this term based on the definition of Bocconi et al. Jeanette Wing actually coined this term in 2006, writing that computational thinking represents a universally applicable attitude and skill set everyone, not just computer scientists, would be eager to learn and use. Later on, Bocconi et al. Looked at different papers and different publications, and they came up with those 6 skills who form this computational thinking skill set. It is therefore the ability to solve problems using abstraction, decomposition, generalization, algorithmic thinking, automation, and debugging. Let's start with abstraction. Abstraction is the skill to see a structure behind a real phenomenon, choosing the focus basically. So to see what is important and what is not. So we want to reduce the complexity of a situation by actually blurring unnecessary details. So in essence, with this skill, we learn how to replace real-world objects with models. Decomposition is cutting a problem into smaller, simpler subproblems that we then actually can solve and afterwards put together to the solution of the original problem. So in math, for example, we have this equation and we want to solve the equation. And by doing this, we then cut this problem into 2 smaller problems, solving x minus 1 and x plus 1. And in the end, we then can get back to our original equation and use those solutions that we found there. Generalization is understanding the space of configurations where the problem lives, basically. So we are recognizing the problem as an instance of a more general set of problems. Or we recognize a pattern in similar and sometimes even simpler problems to find a general way of solving it. So this means on the right-hand side you can see a couple of different figured and colored trees. But all of those 4 trees, they are one representation of this more broader instance of a tree. And on the left-hand side, you see this pattern, and in this pattern, you can use the skill to then find out which of the tiles would fit into the missing lot. The next skill is algorithmic thinking. Many define actually computational thinking by algorithmic thinking. We want to get to a goal through clearly defined steps. So you can think of it as following an algorithm made for getting to a solution through, well, clearly defined steps, being every bit of code that is in an algorithm. The benefit of this is that the steps that we are taking to get to the goal should be not only understandable by machines, so it is not only about writing actual code, but it should also be, or it can also be, understandable only to humans. So we are writing down what we are doing in an algorithmic way where we can then follow through by following only those clearly defined steps. On the right-hand side, you can see something about differentiation. So we start and then we have this, well, clearly defined step on what to apply. And if we are done, well, then it is easily done. The integration is a bit more complicated, saying that we start somewhere. We start with one of those rules, integrating by parts or substitution. And if we are done, yes. But if not, we then start with all of the remaining different aspects of integration, trying to find a solution. So on the left-hand side, the differentiation part, This is actually something that could be called an algorithm because we have clearly defined steps. Automation is going from the algorithm that we just learned about and, well, explaining the problem that we want to solve to a machine. So this means that we are using the computer for repetitive tasks because, well, computer can do repetitive tasks more quickly and efficiently than any human being. For this one, we would need to know about data structure and code structure. So what are loops, for example? This all belongs to automation. Debugging is not only the systematic application of analysis and evaluation skills, but it is also testing, tracing, and the logical thinking to predict and verify outcomes. So we are not only searching for an error, but we can also look at a working algorithm with this skill and see why and how it actually works. So we are mentally going through an algorithm step by step and understanding what it does, how it does, and what the outcome will be. The computational thinking attitudes and pedagogical goals are, well, defined by ISTE, for example, from 2011. We have that it will lead to confidence in dealing with complexity, but also persistence in working with difficult problems, tolerance for ambiguity, the competence to deal with open-ended problems, and the capability to communicate and work with others to achieve a common goal or solution. We also have transversal pedagogical project goals, so we are not only looking at computational thinking, but actually also critical thinking, the collaboration using the app and web portal, the communication that is involved in collaboration, and the creativity to find solutions.